Okay, so in this video we're looking at Leaving Cert Higher Level Maths ExamCraft 2016 Paper 2 Question 9, and it's a geometry/trigonometry question. It says 3 cogs in a machine are designed as shown. The centers of the cogs are connected with metal bars. The belt runs on the outside of the 3 cogs. The large cogs both have radius 3√2. So I know this distance here is 3√2. It asks us to show the radius of the small cog is 6 minus 3√2. Okay, well if I know what am I trying to find? I'm trying to find this distance here, haven't I? That's what I'm trying to find. We can see that there's a right angle triangle very obviously formed here. And we actually know a significant amount about that right angle triangle. I know that's 3√2 as its radius. I know that's 3√2. I know that's 3√2, and I know that's 3√2, and then I don't know this length here. So if we're writing in what we know, let's call this x and x. I know this is 3√2. This is 3√2, 3√2, 3√2, and x. So filling that into Pythagoras' theorem, the hypotenuse is 3√2 plus 3√2, so that's 6√2. That's going to be squared because it's the hypotenuse. I know this is 3√2 plus x. 3√2 plus x squared, plus the other side is 3√2 plus x as well, squared. 6√2 squared is 72, I think. Squared 72, yep. 72, then we need to multiply this out. 3√2 by 3√2 is 9 by 2, which is 18, plus 3√2x plus 3√2x plus x squared. And it's going to be the exact same thing again, plus 18 plus 3√2 plus 3√2 plus x squared. And we have a quadratic equation. 72 is equal to 18 plus 18 is 36. 3√2 plus 3√2 is 6√2 plus another. Okay, and then just manipulating it until we get it down to a nice quadratic. We can divide everything by 2 as well, which is really, really nice. And then we can use the minus b formula. So x is equal to minus 6√2 plus or minus the square root of 6√2 squared minus 4 by 1 by minus 18, which is really, really nice, all over 2 by 1. X is equal to minus 6√2 plus or minus the square root of 6√2 squared, which is 72. 4 times 18, so plus another 72, which is 144, all over 2. So x is equal to minus 6√2 plus the square root of 144, which would be 12, all over 2, or x is equal to minus 6√2 minus 12, all over 2. X is equal to 6 minus 3√2. X is equal to minus 6 minus 3√2. And we're going to ignore the second one, because it cannot be a negative distance. Remember, it's a radius, so it has to be a positive distance. If you put that into your calculator, you'd get a positive distance. The next part of it says, given that CP is parallel to BR, show that ORP is equal to 5.46. Well, CP and BR. Okay, so I'm going to rub this out. CP and BR are parallel. CP is parallel to BR. Okay. They want us to find what? Or P, I think it was, or P, yeah. Okay, well if they're parallel, those green ones, I could draw this blue line in here and know, well, this is 90 degrees, it's a right angle because it's a tangent hitting a radius, so that means this must be 90 degrees. Do I know this purple length? Yeah, I do. I just went and found it. It's the 6 minus 3√2. So I also know this purple length here. And I knew what the full radius was. So I'm able to actually find this red length. it's the big radius minus the little radius. And do I know what this length is here? Yeah, it's the big radius plus the little radius. So let's draw it out again. And I had a right angle, and I said this length was the big radius plus the little radius. So it's 6 root 3. No, it's not. It's 6 minus root 3. No, it's not. It's 6 minus 3 root 2 plus the big radius, which was 3 root 2. So this length is just 6. And this length here was the big radius minus the little radius. So it was 3 root 2 minus the little radius, which was 6 minus 3 root 2. Which ends up being, what is it? 6 root 2 minus 6 is what it ends up being, is this length right here. So then again, it's another scenario where we're going to use Pythagoras. This is the hypotenuse here. So it's the hypotenuse squared, so that's 6 squared is equal to 6 root 2 minus 6 squared, and this is the length that I want, so y squared. 36 is equal to, and I can put this whole thing into my calculator here, 6 root 2 minus 6, close bracket, square the whole bracket, and I'm getting 6.1766 plus y squared. Y squared is equal to 36 minus answer, 29.823. Y is equal to the square root of that. It's 5.46 centimeters. There. So really nice, simple question. Calculate the length of the belt that runs over the cog, correct to 2 decimal places. So the total length of the belt. The total length of the belt is this length. So we've just gone and found that. That is the 5.46. This is also going to be 5.46 because it's symmetrical. This length here, because radiuses hit tangents at 90 degrees, I know that blue length is the same as this blue length here. So it's 3 root 2 plus 3 root 2, which is 6 root 2. So 5.46. 6 root 2. So what other lengths do I need to find? I need to find this length here, the length of that arc, and I need to find the length of this arc down here. Okay, well, the length of an arc is given in the log tables. When it's in degrees, we're going to be using in degrees 2 pi r theta over 360. So the length of an arc is 2 pi r theta over 360. L is equal to 2 pi r theta over 360. So L is equal to 2 pi. Let's do the big one first. 3 root 2. And the angle was 157. It's 157 over 360. L is equal to, put that whole thing into your calculator, making sure we're in degrees. And I'm not in degrees. So that's shift, mode, and then the number 3. 2 pi 3 root 2 multiplied by 157 over 360. And we're getting 11.625. And then we have the other one to do. L is equal to 2 pi, and now it's the smaller radius, so 6 minus 3 root 2. It's the smaller radius and the smaller angle, so it's 46 degrees. Smaller radius and smaller angle. What did I say? 46 degrees, was it? Yeah, 46 degrees. 46 over 360. L is equal to Very similar. You don't need to type the whole thing back into your calculator because you can just go back and edit the bits that are already there in your calculator. 46. 1.41 centimeters. So total length is 2 times 11625 plus 2 times 546, 5.46, plus there's only one of the little radius, and 6 root 2, I think it was. Let's go back and just double check it. 6 root 2 at the top, 2 of the big radiuses, 2 of the 5.46s, and 1 of the small, not radiuses, small arcs, sectors is what I meant to say, not radiuses. Okay, and type that whole thing into our calculator. Plus 6 root 2 plus 2 times 5.46 plus 2 times 11.65 is equal to 44.07 centimeters is the total length. Okay, and the last part of the question then. The cogs are lubricated by oil, which is stored in a shaded region of the mechanism. If the container is 3 centimeters in depth, find the volume of oil. Okay, so we want to find this area here and then multiply it by 3. You've got to imagine this sort of goes deep down into it. It's a 3-dimensional shape. I'm terrible at drawing 3-dimensional shapes, but you can kind of get that it goes deep down into it. Think of all the prisms that you know, like the Toblerone or a cylinder. The volume of a prism is found by finding the area at the face, so this area here, and then multiplying by how long it is. So that's what we're really going to try and find, is that area, and then multiply by the 3. It says centimeters, so making sure all our units are in centimeters. It's really easy to find the area of the face of this shaded bit, because we just need to find the area of the triangle, the whole triangle, which is half the base by the perpendicular height, half the base by the perpendicular height. So what was that length? This is 3 root 2. This is 6 minus 3 root 2. So they're 6 long, aren't they? Yeah, they are 6 long. So the area of the triangle, half base times perp height, area of triangle is equal to half times 6 is 18 centimeters squared. Units are really important. Area of triangle. And then we have really 3 sections we need to take away from that triangle, but 2 of the sections are the same. So this section and this section are the same. And then we have this section here. Now this section here is a quarter of a circle because it's a right angle, and the small radius is 6 minus 3 root 2. So of a triangle, the area of a triangle, or sorry, area of a sector is in degrees, pi r squared theta over 360. The angle is going to be 90 degrees, 90 over 360, 90 over 360. 90 over 360 is area of this bit. 90 over 360 is a quarter. So it's pi r squared times a quarter, pi 6 minus 3 root 2 squared times a quarter. We can put that whole thing into our calculator. Pi times 6 minus 3 root 2 squared times 0.25, 2.425 What else do we know? We know the other sector then. Oh, of the triangle. Really interesting triangle actually, because it's an isosceles triangle. So I know this angle must equal to this angle. How many, so if I'm calling this Z and Z, I know that 2Z plus 90 is equal to 180. 2Z is equal to 90. Z is equal to 45 degrees. So if I was just trying to find this, 45 degrees, this blue area, it's pi r squared 45 over 360, and the radius is going to be the bigger radius, which was the 3 root 2. So it's area of this bit is pi r squared 45 over 360 pi 3 root 2 squared, and that's 1/8, I think it is. And type that whole thing into my calculator. .068 centimeters squared. So the area of the shaded bit, the shaded area, is the triangle. It's 18 minus 2.425 minus 2 times the bigger bit, 2, 7.068. So it's 18 minus 2.425 minus 2 times 7.068 is 1.439 centimeters squared. Okay, so I know the area now of the end. I just need to multiply by how deep it is. So area of a prism, or volume of a prism, is it's called the cross-sectional area. I just like the area of the end times the length. But it has to be that end one where the two areas on either side of the shape are the same. So it's 1.439 times 3. And that is 4.317 centimeters cubed. And does it ask for it in any specific unit? No, it just asks for it, the volume, so you could leave it like that. Yeah, we can leave it like that. A and B were 10 marks, C was 15 marks, and D was 10 marks as well. Hopefully you found the video useful anyways, and it's not too hard.